Material science, the study of different pattern formation of atoms, is called as crystallography. Crystallography is study of different pattern formation of atoms. Crystal structure is arrangement of in different pattern atoms. A crystalline material must have option C repetitive arrangement of atoms in any three direction. A non-crystalline material is categorized as having non-repetitive arrangement of atoms in all three directions. A material having non-repetitive arrangement of atoms over larger atomic distance is called non-crystalline material. A material having repetitive arrangement of atoms over larger atomic distance is called crystalline material. Examples of crystalline materials are option B most metals. Out of the following is non-crystalline material. Option B most polymers. Metals are types of materials crystalline. Most polymers are type of materials non-crystalline. For purpose of study of crystal structures, atoms are assumed as option C three-dimensional spares. The smallest representation of geometry of crystal structure of a material is called unit cell. The arrangement of multiple unit cells together is called crystal structure. A unit cell represents of a crystal structure. Option C geometry. The represents arrangement of unit cells in three-dimensional axis. Option C lattice structure. Lattice structure represents arrangement of unit cells in three-dimensional system. The constant distance between adjacent atoms of unit cell is called as lattice constant. The lattice constants represents difference between adjacent atoms of unit cell. Lattice constants represents distance between adjacent atoms of unit cell. The angle between two lattice parameters of unit cell is called as option B lattice angle. Lattice angle represents angle between two lattice parameter of unit cell. Crystal system clarifies crystal structure according to geometry of unit cell. The geometry of unit cell can be completely defined by both B and C. A simple cubic crystal structure consists of option D A and C. A equal to B equal to C and question equal to question mark equal to 900. A hexagonal closed pack crystal structure consists of option D both A and B. A equal to B. Question C. And A and B. Intoxing or designation in a unit cell can be done for a particular all of the above point, location, direction, plan. A basics of determining index value of a simple cubic structure is unit cell three-dimensional. Circular parenthesis symbolically represents crystallographic plans. Square brackets symbolically represents crystallographic epic directions. Out of the following is used for representation of Miller indices for a single plan. Option C. Out of the following is used for representation of Miller indices for a single direction. Option B. In any cubic crystal structure, the corner atoms shared by adjacent unit cell. Option D 8. In face-centered cubic crystal structure, the face atom is shared by adjacent unit cells. Option B 2. In body-centered cubic structure, the center atom is shared by adjacent unit cell. Option D 0. In cubic structure, crystal structure, the located atoms is shared by 8 adjacent unit cell. Option C corner. A higher value of average number of atoms per unit cell indicates option B higher density of materials. Coordination number is also referred to as ligancy number. Is defined as number of atoms adjacent to and touching a central atoms under consideration. A coordination number. A higher value of coordination number indicates option B higher density of materials. A is defined as of volume occupied by atoms in unit cell. Option C atomic packing factor. APN is defined as ratio of volume occupied by atoms in unit cell to volume of unit cell. A higher value of APN number indicates both B and C higher density of material cells, higher value of average number of atoms per unit cell. In simple cubic crystal structure, there are number of corner atoms. Option C 8. In simple cubic crystal structure, there are number of phase atom. None of the above. In simple cubic crystal structure, there are number of center atom. Option D 0. In simple cubic crystal structure, the average number of atoms per unit cell is option A 1. In cubic crystal structure, the average number of atoms per unit cell is 1. Option A simple cubic. In simple cubic crystal structure, the relationship between lattice constant and radius of atom is given by R equal to A by 2. The average packing factor for simple cubic crystal is given as 0.52. The coordination of number for simple cubic structure is given as 6.